All right, 1A. It says for you to graph it, state the domain range and asymptotes. So, that's why I'm recording it. Yeah. So a couple things, even though it doesn't ask you to do this, but it might help you. When you have a number out here, remember that's up 4. So 1, 2, 3, 4. So I know it's going to run along this wall. So that'd be y equals 4. That'd be an asymptote. It's also it helps you out with the range. And then the negative sign up here would mean that it reflects over the y-axis. So again, I know what you're going to do anyway. If I were to put this in my graphing calculator, just to see what it looks like. I got something that went like this. And goes out that way forever and up. And so my range would be from 4 to infinity. And again, the reason why it was 4 is because it got shifted up 4. And the domain for this one would be all real numbers or from negative infinity to positive infinity because of the fact that we are going to the left and to the right forever.
For range, could you just write y is greater than 4? Or would that be greater than
I suppose. No, not equal to.
Just greater than 4.
Mm-hmm. Then 1B. We have that. Now remember the difference between exponentials and logs when it comes to that. Logs have everything flips. So this time the domain's going to get restricted. The range should be all real numbers. And the asymptote is going to be y or x equals something this time. Now when you have a plus 3 on the inside like that, that should shift everything to the left 3 spaces. So 1, 2, 3. I have the asymptote running north and south this time. And then this would come up in here and go out that way. So my domain was from negative 3 to infinity. The range was all real numbers, or negative infinity to positive infinity. And the asymptote would be x equals negative 3 this time, because I moved it left 3. And again, if you wanted to look at that, even though I know it's not the same base, but if you just hit log and then put x plus 3, that's base 10, just know that base 3 doesn't turn as sharp. The other thing that also happens in there, don't forget, is that when you do this, remember that they do go down forever. Like if you put it in your graphic calculator, it looks like it's going to start or stop in the middle of nowhere, but really that should go down forever. Make sure you put arrows on it. Okay? Number 2. Has f of t natural log of 2t minus 3. And for that one, for the domain, remember that gets restricted. And the key to that is if you were to try and put something in, like if you were to natural log or log 0, that doesn't work. It's not real. Because in the original one, that's the asymptote, or that's where it gets stopped at. So what you do is put this part equal to 0 and solve it. So add 3 and divide by 2. I get t equals 3 halves, or 1.5. And then would it be greater than 1.5 or less than 1.5? So what's a number greater than 1.5? 2. If I put 2 back in there, 2 times 2 is 4, 4 minus 3 is 1, I can natural log 1. If you were to put 1 in there, I could not natural log negative 1 though. So my domain is from 3/2 to infinity. Then to be or not to be. Again, same thing. I cannot log negatives or 0. So what I do is I put that inside piece equal to 0, solve it. So add 1 and then square root. And remember, when you square root, you should get plus or minus 1. Then if I put a number less than negative 1, for instance, like negative 4, negative 4 squared is positive 16. 16 minus 1 is 15. I can log 15. If I put a number higher than positive 1, like 4, 16 squared, I get the same thing. So what happens is, and another way that you could do that to know for sure, is if you graph it, it actually looks like this. It goes out both directions. That's what the graph looks like. So the domain for that would be from negative infinity to negative 1, and then 1 to infinity. Again, why do I have the u in between them? Because I have 2 spots. Okay, if you have more than 1 spot, put a u in between it to symbolize that they're together. That's to be or not to be. 3a. 6 to the 2x equals 5. 25, that is. Write it in log form. So this is just a rewrite. So log of, what's the base number? 6. 25 equals 2x. So remember, the base goes down here. Exponent goes there. Other stuff goes in the other space. Okay, that's 3a. 3b. Now it wants you to write it in exponential form. One of the things with this is, don't forget, natural log is the same as log base e. And this is 100% a rewrite. So e to the third equals a. Or if you wanted to in blue, if you just took e to both sides, you would get a equals e to the third there too. Your call on that. And that's 3b. How are we doing so far? So far, so good? Okay. Four a has 10 log 36. What's the base number if it's not written? 10. And when this base and that base match, they cancel each other out. So what's my final answer? 36. 4b. ln of e to the third. When ln and e are next to each other, what happens? They cancel, so what are you left with? 3. 4c. Log of 3 square root of 27. Now, with this one of the things you could do if you wanted to, there's a couple different routes, but here's one route. If you set it equal to x, because that's what you're trying to find is the answer, you can rewrite this to be 3 to some power equals the square root of 27. And then remember, what do we do for square root? How do we rewrite that? To the 1/2 power, good. And then in this section that this is coming from, we had it be where the 3 and the 27 could be rewritten as the same number. 27 is 3 to what power? Third. Good. So that becomes 3 to the x equals 3 to the third to the 1/2 power. Well, then what happens is these two end up multiplying with each other. What's 3 times 1/2? Yes, 3/2, good job. Then if the bases are the same, then the exponents are the same, so what is it? X equals 3/2, 1.5, 1 1/2, your call. 4D. Log base 2, 80, minus log base 2, 10. Remember the laws here? What is subtraction the same as? Right? So I end up taking the 80 and the 10 and dividing them. And what's 80 divided by 10? 8. And then what happens is just like the last one, we try to rewrite the 8 into 2 to some power. 2 to what power equals 8? 2 times 2 is 4, times 2 is 8. So how many do we have? 3. Good. So if I rewrote that, so instead of setting it equal to x and rewriting it, if I did this way instead, I could do it. Either way, it's the same. The 2's end up canceling, and what are you left with? 3. That's 4D. 4E. Log 8, 4. This cannot be rewritten as the same base. So if I set it equal to x, well, can't be rewritten. Sorry, I said that wrong. Can't be rewritten as 8 to some power, that is. The 4 can't. So if I rewrite that as 8 to the x equals 4, I can rewrite them to both be the same base, but I could not write the 4 as an 8. Okay? What power can they both be? 2. And we just talked about this one. 2 to the third was 8, right? And then what's 2 to what power equals 4?
2.
Uh-huh. And if the bases match, then the exponents should match. So 3x equals 2, divide by 3, and x equals 2/3. For F. On their own, they cannot, but together they're better. What's adding the same as? Multiplying. That's one of the laws. So if I multiply the 4 and the 9 together, what's 4 times 9? 36. Can 36 be rewritten to some power? Like 6 to some power? Probably. What was it? 6 to the second. And if the 6's match, then they cancel and you're left with just the number 2. That's number 4. Five A. Okay, for this one now, we're going to then try to expand, I think. It does say use the laws of logarithms to expand the expression. So basically just expand it is the shortened version. Remember, division is the same as subtraction, and multiplication is the same as adding, and exponents move to the front of the class. So the first thing I'm going to do is I'm going to get rid of the division. So log x, y to the third, minus log z squared. I got rid of the division first. Now I'm going to get rid of the multiplication. Log x plus log y to the third minus log z squared. Is everybody okay with that so far? Then all exponents move to the front. There wasn't an exponent on the first one. There was on the second one. And that's expanded. That's 5A. 5B. I have the square root of x over y. Again, with the square root part, as Ben made a comment earlier, that can be rewritten as 1/2 power. So then, because it is like this, you have two options here. And I'm going to split it into two different problems so that you can see it. One of the options you could take is you could distribute the 1/2 to each of those parts and make it the ln of x to the half. Oops, I don't want to put it there. The ln of x to the half over y to the half. I could do it that way if I wanted to. The other route you could do is move the 1/2 to the front right now, and you'd have it that route. By the way, it ain't going to matter which route I take. They're both going to give me the same answer. Now, how do I split division? Subtraction. So when I subtract this, I get the ln of x to the half minus the ln of y to the half. Over here, I have 1/2 ln of x minus the ln of y. So notice the difference right now. And then on the one on the right-hand side, the half goes in the front and the half goes in the front. On the one on the left, I'm done. Or you could distribute the 1/2 through to each part, and what would you have? Same thing you'd have on the right. So your call on that. If you want to use parentheses to show that, fine. But just be careful, because if you're missing a parentheses or it's in the wrong spot, I'm going to mark some stuff wrong. So be careful there, okay? Just take your time. I know I'm going through this fast, but take your time when you're doing it. Oh, I wouldn't need this parentheses, I guess. I got parenthesis happy there. Okay? And then 5C. Cube root. So first thing I'm going to do, change that to the 1/3 power. And again, I could go two different routes with this one. I'm going to only go one route on here, not going to show you both, but either way you would get the same answer. I'm going to move the 1/3 to the front of it right now. And now I'm going to split. Remember, how does division the same as? Subtraction. I'm going to put the top in parentheses so it doesn't look like I'm taking the log of x plus 2. I'm taking the log of x plus 2. Does that make sense? That I put the x plus 2 in parentheses because I want it to show that it's taking x plus 2 in the log of that, not the log of x, and then adding 2. Minus log x to the 4th, x squared plus 4. That was all on the bottom. Then I got to split up multiplication. Now here's the difference. If it comes from the bottom, it should have a minus in front of it. So you could, if you wanted to, put another set of parentheses there around the whole bottom. Or just know that if it came from the bottom, it should have a negative in the front of it. Like the x squared plus 4 and the x to the 4th should be split. But because they both came from the bottom, that's why they're both negative. Or you could put another set of parentheses in there and put a plus sign in between it. Like this. Look, if I show you in blue. If I were to do this, I'd have to have a third set of parentheses in the back. But then that sign in between those would be positive. Whichever way you want to have it is okay. Now, what's the only part that's not done yet? I got an exponent needs to go. Minus 4 log x. By the way, do you want me to have a plus with the extra set of parentheses, or do you want to have a minus for the back one right now? You guys decide for me, because I don't care. But if I have a plus, then I gotta have another set of parentheses around. You want the minus instead? Okay. Now, the biggest thing that people mess up, do I pull that x squared and put that 2 in the front? No, because that is only on the x, it's not on the whole thing of x squared plus 4. So I do not pull that 2 out. Then another answer that would have been okay, 1/3 log of x plus 2 minus 4/3 log of x minus 1/3 log of x squared plus 4. If I would have ran the 1/3 through to everything, that would have been okay.
So what's in the parentheses, you just leave it?
Huh?
What's in the parentheses, you just leave it?
Yep.
This-
It's got to be on the outside. Another thing that could have happened, another version of the answer, and this is where it becomes a nightmare for me, but more for you because you guys can have more options. We could have also had that. Which one of those 3 are right? They all are. So just be careful. Make sure that you take your time. That one's obviously a little bit harder one. Is everybody okay with 5? (6a) log A plus 2 log B. Now, the directions here say use the laws to combine the expression into a single logarithm. Some of the times it said single logarithm with multiplying, divide, all that kind of stuff. Honestly, all it does is just condense. When you see that, it's just condense. So the exponent goes back up first. And then how do you drop a log? Adding is the same as multiplying. So log AB squared, and that's 6a. Okay. Then from here, there's no exponents in the front, so I'm not going to move them up. So now how do I combine subtraction? Divide. And to be fair with you, right now that's pretty good. However, it's not reduced. Remember, those are fractions. And if you can reduce them, you have to reduce them. Well, x squared minus 25 factors into x plus 5, x minus 5. And the x plus 5s would cancel. So you're left with the ln of x minus 5. That's 6b. All right, first things first, let's move everything to where it should be. This has to go back up, and this has to go back up. And so I've got right now log base 2, 3, minus log base 2x squared, plus log base 2. Now, can I ask you a question? Do you want me to write that as the square root of x plus 1 or x plus 1 to the half power?
It's supposed to be log 2x cubed, not squared.
What?
You move for the second one, it's 3 log 2, yeah.
Whatever.
Oh, okay. Classy.
Do you want me to write square root of it or to the half power?
Oh, half hour.
Half power? Okay. Does it matter? No. They're both equivalent, and I will accept both. Now, when you're going left to right, if I drop the first log off, I end up with this. Then the whole deal is that back part, when you put it into the other two, Does it go on the top or does it go on the bottom or both?
On the top.
It goes on the top because it's adding. And when you multiply, you go across the top. And then you go across the bottom, but not both. So that would be one acceptable answer. Or if you have log base 2, 3 the square root of x plus 1 over x to the third. That would also be okay. And that was what, 6C? Yeah? All right. 7A. 3 to the 4x equals 3 to the 100. Again, like we said a little bit earlier, if the bases are the same, they can cancel each other out, and you're left with 4x equals 100. Divide by 4, and 100 divided by 4 is 25. Seven B has e to the 3x minus 2 equals e to the x squared, I think that says. And again, if the bases are the same, then the exponent should be the same. So 3x minus 2 equals x squared. How do I solve a quadratic? Yeah, move everything over to one side. So I'm going to add all those and subtract all those. So I get 0 equals x squared minus 3x plus 2. What times what gives me x squared? What times what gives me 2 but adds up to be negative 3, negative 2, and negative 1? And if I set them each equal to 0, I get 2 and 1. And if I set them back in there, they both work. Because 3 times 2 is 6. 6 minus 2 is 4, so e to the 4th would equal 2 squared, which is e to the 4th. And if I put 1 in there, 3 times 1 is 3, minus 2 is 1, and then 1 squared is 1, so e to the 1st equals e to the 1st. So they both work. If they didn't work, throw them away. If they're the only answers you got, then you'd have no solution. 7C, 5x to the 10th. Well, I said it wrong, but I wrote it right. 5 raised to the x over 10 plus 1. Okay, now to solve this, first thing I'm going to do, get the exponential by itself. So subtract 1 to both sides. What's 7 minus 1? Then, can I make a 5 into a 6 or 6 into a 5? No. Is there a number that I can bring them both down to make it? No. So now what I do is I log both sides. That allows me to pull this to the front. And then from here to solve for x, a lot of times we divide by log 5 first, just because people don't like the logs there. And how do I get rid of a divide by 10? Yeah, multiply by 10. So the exact answer would be 10 times the log of 6 over the log of 5. The unofficial 10 log 6 over log 5. And depending on what it said to round to, oh, it said 2 decimal places, so I went a little further. 11.13. Do you guys get the same? And then 7D. Can I make a 10 into a 6 or a 6 into a 10? No. So if I log both sides, that allows me to pull these to the front. X plus 3 times the log of 10 equals 2x log of 6. Now the issue is you have x's on both sides, and since you have a multiplication going on with binomial, I'm going to distribute the log of 10 to both. So x log 10 plus 3 log 10. And then I'm going to subtract x log 10 to both sides. So that gives me 3 log 10 equals 2x log 6 minus x log 10. And the reason why I did that is so that I can get my x's to one side, so then using factoring I can take an x out. So 3 log 10 x 2 log 6 minus log 10. So I got it down to 1x, which is what I wanted. And then how do I get rid of times? Divide. And the whole bottom is this stuff. So the official answer, or the exact answer, is 3 log 10 over 2 log 6 minus log 10. And then when you type it in your calculator, to 2 decimal places, because that's what the directions said, 5.39 is what I got. And that's 7D. If it's something like this that has a log on the one side, rewrite it. The base number is 10 when there isn't one listed. So it becomes 10 to the third power equals 2x. 10 to the third power is 1,000. If I divide by 2, what's 1,000 divided by 2? 500. (8b) log of x plus 1 plus log 2 equals log 5x. First of all, there's too many things going on the left-hand side, so condensing those down. Adding is the same as what? Good. So if I multiply the two groups together, and I don't care if you leave it the 2 in the front or the back, that doesn't really matter as long as you know it's being multiplied. And as long as you have it to be where it's log equals log, then this part would equal that part.
Can you distribute two?
Sure. You can do that now, later, whenever you want, whenever you're ready for it. Okay? So then if I subtract 2x to both sides, I end up with 2 equals 3x. And if I divide by 3, what's my final answer? 2/3. Which, when I plug it back in, 2/3 plus 1 is 1 2/3. I'm okay there. 5 times 2/3 is 10/3. I'm still okay there. If it would have plugged it back in and gave me a negative for logging, can't happen. Or 0, can't happen. So then you would have had to throw it away. If it's the only answer you got and you throw it away, then you have no solution. So, but we are okay with 2/3. 8c. 5 natural log 3 minus x equals 4. So first thing you want to do, get rid of any adding and subtracting on the outside, which there wasn't. Then you get rid of any multiplying or dividing second, which there is. So you divide both sides by 5. So I get the natural log of 3 minus x equals 4/5. Then from here, e both sides. So I get 3 minus x equals e to the 4/5. And then from here, to solve for x, subtract 3. And divide everything by -1. So the official answer, or exact answer, is this. Did it say it around? Just let's solve for x, so I could be done right now. Or if you had that, that's the same. One real quick thing, like obviously that was us going through the entire process. Could you have at the beginning typed left side into y1, right side into y2 and see where they crossed? On your calculator? And that would have given you the same answer that I got down here. Could you have done it on some of these other ones too? That we did all these by hand? Yep. Just throwing that out there. That's an option. Okay, what number are you on? 8D? Is that right? Okay, first of all, the adding, you're going to combine those. So because we talked about can we multiply those through right away, might as well do it. So I did. I just saved us the steps of foiling. Okay, I just foiled those two together. Then rewrite. So 2 to the second equals that. What's 2 to the second? So if I subtract 4 to both sides, I end up with 0 equals x squared plus x minus 6. What times what gives me -6 but adds it to be 1? -2 and plus 3. And if I set them each equal to 0, I would get 2 and I would get -3. And looking at that, I have an issue. On the first one, 2 plus 2 is 4, I'm okay. 2 minus 1 is 1, I'm okay. -3 plus 2 is a -1. Can I log negatives? Nope. So this one right here that I'm highlighting would be a no-go. So cross it off. So the only one that we'd have is you just have this. Remember, if you cross off the only answer you have or both answers that you have, then you'd have no solution. Okay? Number 9, change your base formula. You would actually type the log of 27 divided by the log of 12 and get an answer. I got 1.3263. If I go to 4 decimal places. That was number 9, right? Number 10, the initial size of a culture of bacteria is 1,000. After 1 hour, the bacteria count is 8,000. Find the function that models Nort. And remember, NO stands for the initial size, which was 1,000. We don't know the rate. We know that after 1 hour, though, we're up to 8,000 in that bacteria sample. So we can find the rate. Get rid of any adding and subtracting first, which there isn't any. Then you divide by 1,000. What's 8,000 divided by 1,000? 8. And then you natural log both sides to get rid of the e. So the natural log of 8 is more exact. But the rate is 2.07944 if I go that far. That'd be my rate. So your choice here, if you want to write the thing and you want to put the ln of 8 for your rate, or if you want to put the decimal that I put down there for your rate, 100% up to you. I will tell you this, that the ln of 8, if you leave it that way, it's going to be more accurate for you. Okay? The other one will be a decimal. It's a rounded answer. It'll be close, but it might be a little off. And I will accept both.
What if you rounded the decimal?
Uh,
You could say that. I rounded mine to .08.
Okay. So the difference there is if Ben goes to 2.08 and Mandy goes to the one that I have on the bottom, then I go to ln of 8, I'm going to be closer to the actual answer. Because the ln of 8 is a number that goes on forever and doesn't ever stop or repeat. Mandy carried her decimals out further, so therefore it's going to be closer to mine. Ben only went 2 decimal places. It's going to be off a little bit. It's still going to be close, but it's going to be off a little bit. So the further you carry the decimal, the better it's going to be, accuracy-wise. Okay? Your choice. But I'm just saying, if you want to be close, make sure I'd leave it out there as much as you can. So on part B, it says how much is in there after an hour and a half. So if I do this, that's going to be the most accurate. And just to show you, if I do ln of 8 times 1.5, I got 22,627.417. If I were to use Ben's number, 1,000 e to the 2.08 times 1.5, I get 22,646.3796. So difference, isn't there? Okay. Mine's more accurate than his, but we're in the same ballpark and I would be okay with that. Okay. If you're way, way off, then I got to double check and see what numbers you put in. Okay. That's part B. C, how many hours will it reach? 15,000. So 15,000 goes here. 1,000 goes there. Oops. E, ln of 8, R, T, if I divide by 1,000, what's 15,000 divided by 1,000? Good. Natural log both sides. So I get the ln of 15 equals the ln of 8 t. So then in my calculator, when I divide both sides by the ln of 8, I get the ln of 15 divided by the ln of 8, which I got a time of about 1.3 hours. Is it in hours? Sketch a graph. You guys plug that in your calculator and see what you get. Biggest thing is when you're plugging that in your calculator, the first initial is 1,000, which means that's going to go up 1,000. So if you're only at 10, you ain't going to see it. You got to move that window up. Okay? We don't have to go very far out because we're only going like 1.5 hours was 22,000 something. So we might have to go like 1,000 up to like 50 or so thousand, but only go to like 0 to 5. And you should see a decent window. Should be a nice curve going upwards. 11. Suppose the 12% or $12,000 is invested in a savings account that pays 5.6% per year, compounded monthly. So anytime you see the word monthly, you're using this one. So 12,000 was my initial investment. 1 plus 0.056 was the rate. Monthly is 12 months in a year. There's my equation. Part B, find the amount in the account after 3 years if it's compounded daily. So they button hook you a little bit. 1 plus 0.056, then you go 365. 365 times 3, which you can type that all in if you want to get your answer. And I get approximately $1,495.06 if I round. Part C, how long will it take for the amount to go to 20,000 if it's compounded continuously? So continuously, remember, is the PERT. The rate was 0.056, and you don't know the time. So just like we did on the other ones, divide by 12,000 first. So if I reduce that, what is that, 5/3? If I reduce it? How do I get rid of E? Natural log it, good. So I end up with the natural log of 5/3 divided by 0.056 equals that T. And the time I got was 9.12 years. A, just so you guys know, I will not ask you for a decay formula with the 2 in there. If I ask you for a decay formula one, I will not ask you one that has the 2 in there. So 12A, I'm not interested in. We're not going to do that one.
Do they give you the same answer?
Yes. But 12B, I like the rates more. That's just me. When it talks about mort, just remember that the R is the ln of 2 over the half-life, whatever the half-life happens to be. Looks like it's 10 seconds. And it contains 3 grams at the beginning. So there's my formula. How much is after 1 minute? Here's the catch. You don't put 1 in for T. What would you put? 60. Because it says in seconds for the half-life. So the time also has to be in the same unit of measurement. So 3 E negative ln of 2 and after that I got 0.0469 if I round grams. How long will it reach 1 microgram? Again, that's where you'd put 10 to the negative 6 on this side, 3e to the negative ln of 2 over 10 t. Solve for t. We've already done a few like this. They're just the same things, just over and over again. Divide by 3. So whatever that number happens to be, it's probably not very user-friendly. Natural log both sides. And then divide by all this. And that'll give you the T. So if you type that in, that should give you how much time it took to get to 1 microgram. And 13, an earthquake measuring 6.4 on the Richter scale just struck Japan earlier. Minor earthquake was 3.1. To find the differences, you subtract the 2 magnitudes. And it's 10 to that power. And whatever you get there, that's your final answer. That's how much more times the tense one was versus the other. And I went over by 30 seconds. Did you think I was going to not finish? Boom.
Oh, also, right?
Yep.